All right, today's lesson is 11.5, areas of similar figures. And we are going to find areas of similar figures by using a scale factor, something that I understand you guys did last semester in chapter 7, which was before I got here. So I'm trusting that you'll remember at least a little bit of that. And then we'll also find scale factors or missing measures given the area of similar figures. So we're going to find the areas of similar figures given the scale factor, and then we're going to find the missing measurements given the area. So kind of two different ways of working similar problems. The one theorem that we have in this lesson is the theorem for areas of similar polygons. And so if ABCD is similar to FGHJ, then the area of FGHJ over the area of ABCD is equal to the scale factor. So side FG over side AB would give you the scale factor. So the areas compared as ratio are the same as the scale factor squared. And that's the important part of this right here, is remembering to square the scale factor in order to use the information from the areas. So really all I've got for you today is about 4 or 5 problems to work through and some examples for you to see, and then that's pretty much what you'll have on your homework. First question, if JKL is similar to PQR and the area of JKL is 30 square inches, then find the area of PQR. The first thing that we need to do is find the scale factor. Scale factor is going to be 12 over 15. Simplify it. 4 over 5. And now I want to find the area of PQR, so I need to use the scale factor between the two shapes, but I need to do what first? Got to square it. So 4/5 squared would be equal to 16 over 25. And now I can use that squared scale factor in order to find the ratio of the areas of the similar figures. So if I know that this one, JKL, is 30 square inches, 30, now does 30 need to go on top or on bottom? It needs to go on top because I've got the side measurement or the side length from that triangle on top of my scale factor. So 30 needs to go on top, which means put an X here, and 16 over 25 goes here. And now you just have to solve the proportion. 30 times 25 divided by 16. 46.9. 46.9 inches squared. Colton.
Where did you get 30 again?
30 was given in the problem. 30 square inches.
Oh.
Yeah. Yeah, this is pretty much what we're doing today. We're going to use this type of ratio and solving proportions over and over today. All right. We'll do the same thing with this problem that we just did. We're going to set up a scale factor. So we've got 8 over 5 can be our scale factor. And it won't simplify, so all we have to do to find the scale factor of the areas is square it. So that becomes 64 over 25. And now we can use the area of the large figure here that we know to find the area of the small figure. So it's 32 over x equals 64 over 25. 32 times 25 divided by 64. X equals 12.5 centimeters squared. So the area of this green one is 12.5 centimeters squared. All right, the second half of the lesson is doing the, given the areas, can we find the missing side length? And so it's basically using the same type of procedure, but we're just going to find a different part of the proportion. The area of ABCD is 150 square meters. And the area of FGHJ is 54 square meters. So we'll just set that up as a ratio, 54 over 150. And now I want to find the scale factor, not of the areas, but the scale factor of the side lengths. So the first thing I want to do is simplify. 54 over 150, if you divide both of them by 6, you'll get 9 over 25. So 9/25, and that's the scale factor of the areas, but I want to know the scale factor of the side lengths. So on the last page, we squared it to get what we wanted. What are we going to do this time? Square root. We're going to go backwards. So it's going to be the scale factor of the side lengths is 3 over 5. And now I can use 3 over 5 equals x over 10. 10 times 3 divided by 5, x is 6. 6 meters. So we're able to work the process backwards to find the missing side lengths. That's all we're doing. Okay, one more example, very similar to the last one. Find the ratio, or set up the ratio of the areas. So 400, and I like small numbers on top. So 64. Simplify it. 16 goes into 64 4 times, and 16 goes into 400 over 25. Yeah, 16 goes into 425 times. So 4/25, take the square root. So that's 2 over 5 is the scale factor of the side lengths. So 2 over 5 equals what? X over 40. X has to go on top because the smaller size is on top. So, yep. Ooh, I didn't draw that right. I drew it backwards. 40 times 2 divided by 5 is 16. So X is 16 millimeters. That's pretty much it for today.
That's pretty easy.
There's your assignment.
Are there a bunch of trick questions? That's okay.
I don't think so.
I really like that one.
Are you still recording?